If you are excited about 3D modeling and want to know the basics of how it's done, then you've come to the right place. In this video, we are going to explore the basics of file types and programs used to create 3D models using the augmented reality metaverse over as an example. The task I took on was to lay out all of the basics of 3D modeling into a primer that I could use for my existing team of software developers at Fractal Labs as we begin to onboard gaming developers. For me, learning needs context, so I gave myself the task of creating and submitting a competitive entry for the AR Awards by Over. The end result was this. And if you keep watching, you'll learn how I did it and get a crash course in all there is to know about file management for AR experiences. By the end of this video, this will make sense. The first thing to understand is that until recently, 3D design, the building blocks of extended reality, has been extremely proprietary and siloed. Although several industries have been using 3D modeling for decades, programs were essentially non-overlapping and the file types were incompatible. Here are a list of examples. DNV is explaining how computing software, OCX, can be used to generate better design tools for boats. OCX is not a file type most designers would run into. Like most 3D modeling tools, it is industry specific. Business to Community explains for individuals embarking on product design the differences between rendering, mesh, and CAD images, which are usually exported as STL. STL is another file type, and it isn't used very often in the extended reality world. This poster describes an advanced computing technique that they call curviness saliency for 3D images and multi-scale curviness saliency for 2D images to render practically identical 3D models. Here, they're pitching it to be used for object registration, a tactic that game developers or movie makers wouldn't really have a use for. Here's an interesting use case for 3D models. Soft robots are being designed to inflate to prescribed 3D models. Super cool. This is particularly of interest in the medical field and even more particularly of interest in the medical patenting field. This has proprietary written all over it. If that was over your head, don't worry about it. I was just trying to give you an example of different ways that 3D models are used in different industries and how non-overlapping they can be. To make 3D models, one uses computer-aided design, also known as CAD. So if you've heard of CAD before, that's what it means. It's just having a computer that helps you create a design. There are dozens of CAD tools on the market, and today, several of these are open source and free to use. Because of accessible CAD tools, 3D models are now interchangeable, and utilized by a wide variety of creators. And it has created a de-siloed segment of the industry. So we can now share our models and have them be used by others to create a multitude of different things in a multitude of contexts. To make sense of this all, we can group types of 3D models into 5 categories. 1, 3D visualizations, also known as mockups. Why this ends up in its own category is that typically these are not images that rotate. You only need one single point of view. Here we've got 2 points of view, but those are 2 separate images put side by side. It's not a model that requires the ability to rotate and see underneath or behind or from the side. Category 2. 3D models for AR and VR are different than the product visualizations because they actually have to be able to rotate and be seen from all different angles so that either the player or the designer can place them in different positions and utilize them as if they were real on Earth. 3. Architectural models. Architects use computer-aided design to create 3D versions of 2D blueprints, and these blueprints aren't only used by the construction team or the architect. These models are also going to end up being used for the interior designers as well as the sales team. 4, 3D printing models are used to create IRL objects. That's right, you might be creating a 3D model for the purpose of making it very, very real on Earth. Something you can touch, hold, you could lick it if you wanted. 5, 3D animations for movies and games. This is very similar to the AR VR category. I gave it its own spot because in these scenarios, there are shifting camera angles. Because my goal was to create an AR experience for OVR's AR Awards, that really narrowed my search. To figure out what file types would be needed, I made a list of the programs I thought I would need to use, and then listed all of the file types that those programs use. That way I could find which one was compatible across the board. Unity would have been really nice to include because that was the program I would need in order to create interactive content in my experience, but that proved to be out of scope for this project. GLB was the overlapping file type, so I focused on just that and source models that were already made by designers from Creative Market and Sketchfab, which is a marketplace for 3D assets. When I couldn't find what I needed in GLB, I had a designer export it into GLB for me. That gave me a bank of assets in the right format that I could use directly in the OVR Builder. Let's talk about that builder. This is a program that is offered by OVR. It is seamlessly integrated with the mobile app. I can publish the final product directly from here. After uploading my models that are formatted to GLB, I'm ready to play.
Play is super essential because this is how we learn how the models interact with each other. There's no way to simplify it without doing it yourself. But once you've got everything in the format that you need and loaded, this process can be super intuitive and you get to just enjoy learning.
So what did we learn? I was able to build this using assets created by other designers. I could then arrange them inside of the OVR Builder until I had my desired results. I'm tempted to create a second video where I explain all of the artistic choices that I put into this. It's based off of the original first ever science fiction film, and I really put my heart and soul into what is there where it is and why. So if you'd be interested in that kind of video, let me know, and I'd love to walk you through my process. With the free OVR app for mobile, you can experience this live yourself for free. You can just download it and navigate to the land named woods.assume.believing. That information, as well as credits to all of the images I've used so far, is included in the description box below.
All right, let's look at this diagram again. I showed you this at the beginning and promised that you would understand what's going on. So on our left, we've got the CAD software. These are the tools that actually create the models themselves, and we've got several to choose from. The output of that software are the models. GLB is what I use a lot. FBX and Blend are also going to show up very often. From there, we can put them directly into the OVR Builder, which will be renamed to OVR certainly at some point soon because they are slowly changing their name to OVR across the platform. Or the game engine can be used to create anything game-like. If you want the user to be able to throw something or open a door, do anything interactive besides clicking a link, then the game engine is required. If you're using Unity, that can be exported directly to the OVR Builder, or you can use the game engine as if it was a CAD software to generate models.
As a free gift to you, I'm sharing the 3D modeling primer that I created for our developers. You can download it, it's free, and I hope you use it. I hope you love it, and I look forward to your constructive feedback in the comments. What I'm still wondering is, how hard is it to become the creator of the 3D models? I want to continue creating experiences. Is it good enough just to know how to work with them? Or is it best practice to have the model creator be the same person who puts them into a scene? Bye.